Hi guys, I'm going to talk about the cranial skeleton, but I'm going to do it in two pieces. So normally how I would talk about the cranial skeleton is I would put you in my comparative anatomy lab and we would pull out 15 different skulls, including humans, and wander our way through the various bones. Because yeah, I get it. This course is called Human Anatomy and Physiology. But if you can get it from a non-human perspective, it makes the human structure make so much more sense and so much easier. So the first part of this is going to be a slide on PowerPoint. And then I'm going to go record downstairs on the anatomage table, bouncing back between anatomage and my office. Turns out it's kind of been a pain in the butt, but whatever, we're working it out. So I'm going to go through a single slide. It's going to compare a dog to a human, and then probably not tomorrow because it's my daughter's 7th birthday, but I'll finish the rest of the lab very soon, and we'll go from there. So what I'm going to do is I'm going to share the screen, pull up a PowerPoint slide showing you some things, and then, goodness, I wish I could get you guys in the lab, because you pull up a dog and a deer and a rabbit and a human and you look at them all and you see all the commonalities, it just makes more sense. But I'm going to try to do that a little bit today. This is kind of new. So I'm going to share the screen. Uh-oh. Share the screen. There we go. Share. Okay. Here we see, obviously, a human. And if it's not obvious, that's a dog. And the cranial skeleton is comprised of a bunch of bones. If you took my comparative anatomy lab, for example, the maxilla, which is down here, or the mandible, I should say, is comprised of about 5 different bones. In mammals, it's pretty much a single one. If you look closely at a real skull and hold it in your hand, you'll notice that there's a bunch of holes. And that's where the nerves and the blood vessels go through. I'm not going to spend a whole lot of time talking about the differences in the dog versus the human, but I do truly think it makes more sense to learn them first on a different animal, and then we're going to switch to a human. So what we have down here is we have the pre-maxilla, which we have in the human. It's right down there, but it's not really obvious. Then we have what's referred to as the nasal bone. And the bones were named after the part of the brain over which they lie. So here we see the nasal bone, which overlies this incredible olfactory cortex of the dog. And in humans, if we look over to the left, the nasal bone is fairly small, because the olfactory bulb in humans, compared to the size of the rest of the brain, is a lot smaller. Then we have a maxilla, and the definition of the maxilla, it is the bone that oversees the teeth on the upper side, and the mandible oversees the teeth on the lower side. This is an area called the orbit. Obviously, you see this in a human as well. And these are 2 different bones, but I'm not going to make that distinction, because in the human, we call the whole thing the zygomatic bone. That's technically the jugal bone. Oops, uh-oh, what happened? Sorry about that. This is technically the jugal bone, but who cares? Because in humans, it's all fused, and we call the whole thing the zygomatic. So we have the nasal bone, we have the frontal bone, which is right here. It actually is right on top of the frontal lobe of the brain. And in humans, the frontal bone on this figure, there it is. Okay, sorry, I was going to say it's not labeled. It has to be labeled. There's the frontal bone of a human, and it overlays the frontal lobe of the human cortex. Then we have the parietal bone, which overlies the parietal lobe of the human bone. I'm sorry, of the brain. And back over here, we have the parietal bone of a human. In the human, we see these sutures. You see them also in non-humans, but it depends upon the type of image that you look at with the human to see where they are. Sometimes in many of our models, if you look at one of my plastic models, you won't see these sutures at all. This is the coronal suture, and then there's the sagittal suture across the top, and those sutures are joints. These are all individual bones. And when you're born, those sutures are not necessarily as close together as they end up being because the cranium grows and eventually it fuses together. If we go to the back of the skull, we see the occipital bone. And guess what? There's the occipital. It overlays the occipital lobe of the human brain. We get down to the mandible. And if you look at non-mammals, as I mentioned, this mandible is multiple bones. In humans and most mammals, it's pretty much a single bone. You don't see the sutures. You do see, for example, an angular process, which is really not that existent in a human, but you do see the condyloid process, which is sitting right up here. And then you see this huge flat spot right there. What did we talk about with something like the scapula? The flat spot in the bone is for muscle attachment. And you see that exact same thing in a human. It's right over there. So if you look at moment arms and pure physics, you can press pause and think about it, but it won't take you very long. Which of these two skulls do you think has a greater power for grasping the jaw? Also, if you look at moment arms from basic physics, this one is a lot longer, which means it's going to be faster. We've got more power, we've got more speed. And goodness, I wish I could bring you guys into my comparative anatomy lab and we could take a look at all of them. We're not going to get to a lot of the bones. There's a number of them inside the upper jaw, and a number of them towards the back where we introduce the cervical vertebra, but we're not going to have a whole lot of time. There's a few inside the nasal region itself, but this is pretty much what we want to get to. So here we have, if you go to the human, we've got the frontal bone, the parietal, the occipital, the temporal bone, and we can see that temporal bone in the dog also. The temporal bone overlays, shocker, the temporal lobe of the human cortex. So these are the bones of the cranial skeleton. We're going to get into a little bit more detail in that. I'm going to show you these on the anatomage table. I'm going to pull up a dog and a human and rotate around. I still haven't gotten the first lab study guide posted, but I will have the terms that you will need to be able to identify. Almost all of them are on these two figures. We're not going to spend a whole lot of time on the teeth because human teeth, to be honest with you, are not terribly exciting. I've got a friend of mine who is printing me a 3D print of a hyena skull, and hopefully someday I'll show that to you just for pure educational interest. We have incisors and canines and premolars and molars and all that sort of thing. We have the same thing with a human, they're just not as well developed. And many times in my other classes, I've given folks a skull and say, what do you think this animal eats? Based purely on the teeth. And do you think that jaw is fast or is it strong? And we'll talk a little bit about that, not too much. We're going to focus almost entirely on the human dentition. But that is an introduction to the cranial skeleton. It's not tremendously detailed, but it's appropriate for right now. And then I'll go into much more detail when we get to the anatomized table and I record from down there. And I'll show you some better 3D renderings where I can rotate these skulls around, because obviously these are 2 dimensions and I can't move them. All right, so there's part 1 of the cranial skeleton. Have a beautiful, whatever time of the day it is.